Okay, calculus, let's do some real-world problems with related rates. So first off, one thing I want us to do is to be able to take a sentence and then convert that into an equation. So when we have, for example, let's look at a real situation here. My height increases at a rate of 3 inches per day. We're going to think about this as like, okay, your height is increasing. So that h, the derivative of h is going to be 3. So dh dt is equal to 3. Like taking a sentence like that and turning it into some variable, some derivative variable is changing over time, right? Let's look at something else. So like my IQ decreases at a rate of 5 points per day. It was increasing up until this quarantine. So let's see, because it's decreasing, when you see something's decreasing, that means of course it's going to be negative. So this would be like a di dt is actually negative 5. So when you see a sentence like this, something is changing at a rate, or they give you some kind of like points per day like that, that's telling you that it's a derivative, and we want to write it like such. Okay, so I have 2 problems I wanted to share with you today. Let's say this. The height of a wasp nest, yuck. So the height of a wasp nest, wasps, by the way, very dangerous, is h equals 10, that's a bad h, 10x over x plus 1 inches, where x is the width of the nest. This width decreases at a constant rate of -2 inches per day. And our goal is to find the rate at which the height changes when that x, that width, is equal to 4. Okay. So some of the things that I like to do when I approach a word problem like this is I like to think about like what is given, and then what do we need to find? Okay, so what is given to us in this problem? Well, they told us this relation, right? H equals 10x over x plus 1. They told me that this width decreases at a constant rate of -2. So if x is the width, they're telling me dx dt is -2. And our goal, what we're trying to look for, is the rate that height is changing when x equals 4. So my goal is to find a dh dt, that's the rate at which the height changes. Find dh dt when x equals 4. When you're addressing these problems, this is what you should do. Start by figuring out what do we need to find, what do we actually have. Okay, so once we know what's given and what do we have to find, let's now just take the equation and then do what we've been doing in the last video, differentiate and then plug in. Okay, so I'm going to start with h equals 10x divided by x plus 1. So when I take the derivative of this, I'm taking a derivative, again, with respect to time. All my derivatives here are dealing with time. So that's saying dh dt equals, I'm going to have to use the quotient rule here. So low d high. Derivative of 10x is 10 times the dx dt. We need that chain rule. Minus high d low, derivative of x dx plus 1, derivative of 1, 0. Square the bottom. Away we go. Okay, so now I took the derivative. Now I just need to go ahead and plug in. So they told me dx dt is -2 and x is 4. I think that should be good enough for me to go ahead and figure out what this dh dt is. Okay, so the dh dt, the x is 4, so that's going to be 5 times 10, dx dt is -2, minus 10 times 4, and the dx dt is also -2. And then the x plus 1 is just 5 squared. Okay, so what are we going to get? Oh, geez. So we're going to have -100 plus 80 divided by 25. So we're going to get -20. That actually worked out nicely. But I also want to think about units, right? So thinking back to our last video, we're going to take the units. Oh no. Oh, gosh, what did I do? Okay, sorry. So we're going to do the units of h divided by the units of t. Well, going back to the problem, what does it tell me the units of h are? What does it tell me the units of t are? So the t, they told me, is in terms of days, and the h is in terms of inches. So I'm using these two pieces of information. It's always going to be given in the problem. So h is in terms of inches. If they don't give you units, don't worry about it. And t is in terms of day. So that tells me the rate at which the height is changing at that point in time. Okay. So that's how you address a problem like that. We're going to also see a couple of problems that deal with circles. So just some things to remind you about circles. When a equals pi r squared, that's the area. The circumference of a circle is 2 pi r, and the diameter of a circle is 2r, twice the radius. Okay, so let's do an example here. BP spills oil in a circle. This isn't as funny as it was back in 2005. And the area changes at a rate of 10 square miles per hour. And your goal here is to find the rate of change of the radius when the diameter of the circle is equal to 10 miles. Okay, so let's see. We have oil spilling in a circle. It's going outwards. And how do we, first off, let's write down what we're given. So we're given here, area changes at a rate, so that's a derivative, dA dt, of 10. So dA dt is equal to 10. Find the rate of change. They also told me the diameter is equal to 10 miles at this point in time. So we're trying to find the rate of change of the radius. So they're asking me to find dr dt at that point in time. Okay, so when we have an equation, right, we're dealing with an area. So we should probably start with our equation for area. Now, I passed geometry, so I know the area formula is pi r squared. So now I'm just going to take the derivative and I will plug in. So I'll take the derivative of both sides here. Okay, so my dA dt is equal to, okay, so on the pi is a constant. The derivative of r squared is 2 times r to the first times the derivative of r. Okay, so what do we know, right? We know dA dt is 10. We do not know the radius, or do we? Right, like we don't know r, but we do know that the diameter at this point in time is equal to 10. Okay, if we know the diameter, do we know the radius? Yeah. So we know the diameter, it means twice the radius. That means the radius at this point in time is actually just 5. So that means this is pi times 2 times 5 dr dt. So that means that my dr dt, the 10's cancel, is just 10 over 10 pi, or 1 over pi. In terms of units, what are the units of r? Well, I think this was in terms of miles, okay, and the t was in terms of hours. So that dr dt would be in terms of miles per hour. And again, that tells me the rate of change of the radius. Make sure you're putting the units whenever they're appropriate, and that's the problems, right? So you have some kind of equations, think about what is given to you, what are you trying to find, and hopefully that'll be a guidepost for you along the way. Okay, let me know if you have any questions. Good luck, and I'll see you all soon. Thanks.